Okay, first bit of this is really what we were doing last lesson. So given second derivative plus 4a is 5 cos 3x has a particular integral k cos 3x, find k to start with. So normally you would do lambda cos 3x plus mu sine 3x for your particular integral. I just did that actually to see what happens, and actually mu comes out as being 0. So this kind of just eases your workload a bit, but you are sometimes given the particular integral to use, so I'll just go with it. So first thing to do is find the auxiliary equation, which is m squared plus 4m, oops, no, just 4, I'm just having a middle one in there, equals 0. And so from there, m is equal to plus or minus 2i. And so from there, we can get the complementary function as being, so it's e to the power 0, because there's no real part, a cos 2t plus b sine 2t. E to the power 0 is just 1. So we've got a, oh, I didn't go into 2's. My example earlier was in 2's. A cos 2x plus b sine 2x, which e to the power 0 is 1. So we get a cos 2x plus b sine 2x from there. Then using the particular integral, k cos 3x, then if I differentiate that once, cos goes to minus sine, so I'll get minus 3k sine 3x. And then differentiating again, I'm going to get minus 9k cos 3x. And then substituting into our initial equation, we've got minus 9k cos 3x plus 4k cos 3x is equal to 5 cos 3x. So minus 5k cos 3x equals 5 cos 3x, and so it follows that k is equal to minus 1. So the solution to this, y is equal to complementary function plus particular integral, which came out as being, where am I, minus 1, so minus cos 3x. So that's that bit. And then just sort of adding the last bit on is actually just finding the values of the constants at a and b. So we want to find the solution given that when x equals 0, y equals 1, and divide dx is equal to 2. I'll just pop the equation back on this board. Right, so when x equals 0, y equals 1. So this gives me 1 is equal to cos of 0 is equal to 1. Sine of 0 is 0, so that's just going to 0. and cos of 0 is 1. And so it follows from there that A is equal to 2. And now I need to find dy dx and set that equal to 2 when x is 0. So dy dx, I know that A is 2, so I can do that, can't I? So dy dx is going to be minus 4 sine 2x plus 2b cos 2x plus 3 sine 3x. And then we know that dy dx equals 2 when x equals 0. And so that should be enough information to find b. You could collect all this together, but I'm being slightly lazy. So 2, sorry. Sine of 0 is 0, so that's just going to 0. Cos of 0 is 1, so it's plus 2b plus 0. So it follows that b is equal to 1. And so from there, sometimes depending on the particular integral, you get a couple of simultaneous equations from there, but it won't get any worse than that, I promise. And so y is equal to 2 cos 2x plus sine 2x minus cos 3x. I've just realised I said something stupid there. You can't collect them together because you've got a 2x and a 3x. So I was just being lazy. I hadn't really looked at it properly. So that's not going to look any better than that. To there. And we'll have a play around with graphing these when we look at simple harmonic motion and just sort of get a feel for some graphs as well. But yeah, we'll focus on this lesson. And then we'll look at applying it next lesson, I think. So yeah, there you go.